Good evening, everyone, and thank you for being here today. It is with great enthusiasm that we present our project Tic-Tac-Toe with Minimax and Alpha Beta cloning. This project combines the simplicity of a classic game with the complexity of artificial intelligence algorithms to deliver an engaging and efficient experience. Hello, I'm Nafis Arafat, and my team members Fahim Muntasir and Soed Minhaj Ahmed have worked collaboratively on this endeavor. Together, we aim to demonstrate how advanced concepts in AI can be applied to everyday applications. On the next slide, we are going to discuss about the table of contents that we have attached on this slide. Our main objectives of this project were to develop a GUI-based tic-tac-toe game using Python and tkinter to implement the Minimax algorithm with alpha-beta pruning, ensuring optimal and efficient AI decision-making, to create an interactive, user-friendly interface using event-driven programming principles to enhance the game's visual appeal with gradient effects and custom design text, to ensure seamless gameplay by integrating robust logic for detecting game outcomes such as wins, loss, and draws. On the next slide, requirements. To achieve these objectives, we defined clear requirements for our project. First, the implementation of a 3x3 tic-tac-toe grid that displays moves using X and O. Secondly, we designed two gameplay modes, human versus computer, while the player faces an AI opponent with adjustable difficulty, computer versus computer, demonstrating how two AI players can compete using varying levels of intelligence. The cornerstone of this project is the integration of the Minimax algorithm with alpha beta pruning, enabling the AI to make optimal moves while reducing unnecessary calculations. Finally, we established scoring rules such as plus 10 for wins and minus 10 for losses to guide AI decisions. Next, the adversarial search. Adversarial search Adversarial search lies at the heart of this project. It is a fundamental algorithm in game theory, particularly using for environments where multiple opponents make alternating moves. The goal is twofold: to maximize our own advantage, to maximize the advantage of the opponent. In the context of tic-tac-toe, adversarial search allows the AI to anticipate and counteract human moves efficiently. This strategic foresight creates an intelligent computer opponent capable capable of delivering optimal or near optimal gameplay experiences. Next, the Minimax algorithm slide. The Minimax algorithm is a critical component of adversarial search. What is it? The algorithm minimizes potential losses for the initiating player while maximizing their potential gains. It evaluates all possible game states to select the move that leads to the best outcome. While it is used in tic-tac-toe, Minimax ensures the AI makes intelligent, well-informed decisions by carefully analyzing all feasible moves and predicting the opponent responses. This level of strategic thinking evaluates the gameplay experience and ensures fairness in matches between human and computer players. Now, I would call Soed Minaj Ahmed to represent the next slides. Thank you, everyone.
Thank you, Nafis Arafat. So I'm going to talk about the alpha-beta pruning algorithm, which is an advanced version of Minimax algorithm. The alpha-beta pruning serves as a crucial technique within the Minimax algorithm designed to curtail the number of nodes. And even within the relatively small game tree of tic-tac-toe, alpha-beta pruning remains an invaluable tool for optimizing the decision-making process of the AI. We have two game modes here. One of them is human versus machine and another is machine versus machine. Now we will look at the code of the project. First of all, here we have initialized range 9 because of 9, as we have 9 cells in the game. Then we have used a function for the winning combinations according to rows, columns, and diagonals. There are 8 winning combinations. Then we have used a loop to identify the combo. Then we have used a function board is full to check if all the cells of the canvas is full or not. Then we have implemented Minimax algorithm here. The Minimax algorithm and the alpha beta pruning determines the best possible outcome for the AI. Then the Minimax algorithm is a recursive function that evaluates the possible future states of the game. It recursively simulates every possible move, assigns scores, and returns the best one from the current player. The maximizing player indicates, here we have a maximizing player that indicates whether it's the AI's turn or the opponent's turn. Alpha beta pruning helps to cut off the branches in the game tree that do not need to be explored, improving the performance of the algorithm. We have a function to find the best move uh, that determines the best move for the AI using the Minimax algorithm, and the function iterates through all empty spaces for X and O in each empty space and evaluates each move using the Minimax algorithm. It returns based on evaluation. Then we have AI versus AI mode and human versus AI mode. In AI versus AI mode, it runs AI versus AI match where both players are controlled by the machine, and human versus AI mode enables when when human player clicks a button, the function places on X on the top of the board. It then checks for a winner or draw. If the game is still going on, then AI makes it move. Then the AI versus AI or human versus AI handles the mode selection and starts the game based on selection mode. Either AI versus AI or it pass is invoked. The set mode function updates the button color to highlight the selection mode and starts the game. Then we have initialized tkinter tkinter for GUI setup in the game window, and the TK window is created and configured. Two buttons for the mode selection are created and placed on the canvas. Nine cells are created for the tic-tac-toe game board, which represent cells. They are placed using create window function to organize them in 3:3 grid. And in the last we have root.mainLoop function, which enables the game loop runs and allow the user to interact and update the game state according to their convenience. So that is all from me. Now I would like to invite Fahim Muntasir to discuss about the project report and talk about the further on this project. Thank you.
Thank you, Sir Minaj Ahmed. So now I will represent the rest of the project. So I will talk about the report. So this is the developing tic-tac-toe game with Minimax and Alphabeta cloning algorithm report. This is the objective, and we already talked about the objective and the requirements. Now here, the output. As we can see, the game is about the human versus AI and AI versus AI. And here is the next picture is the result of human versus AI and AI versus AI. So here we can see the player 0 wins, and the last photo. So here we can see the when human makes a move, then AI analyze the move, and then AI takes his moves. So it's a draw game. As we can see, it's a draw. Next slide, please. Here, the adversarial search. Nafis Arafat Rahman already talked about the adversarial search, so I'm gonna skip it. Game modes. We already know that it's a human versus AI and AI versus AI, and it's maximizing player tries to maximize the score, and maximizing player opponent tries to minimize the score. The alpha beta pruning. Here, AI move selection, AI move section selection. So here, the initialization part is the first. This function takes two parameters, board and which represents the current state of the tic-tac-toe board, and is AIX is a boolean indicating of the AI is playing as X. And second is the iterate over the board. Third one is the temporarily place AI maker. Scroll down a little. So here, the temporarily place AI maker for each empty position board I, and the function places AI makers in that position. If is AIX is true, it places X, otherwise it places 0. And then AI versus AI mode. So in AI versus AI, the two AI players use adversarial search alternately to make their moves. Here is the function. I already described this function. Sorry, now I will describe the function here. So this snipped appears to be, we use the Python code here, and first of all, we check if there is a winner on the board by verifying winning combinations. This is the check winner board, and second one is function to check if the board is full. So we checked here if the function is full, indicating a draw, if no winner. Third one is it implements the Minimax algorithm with alpha beta pruning to find the best move for the AI. And then we find the best moves, initializes the Minimax algorithm to find the optimal move for the AI. On-click handles user input by processing a player's move and checking the game state. Computer move. So the computer move handles contains logic for the AI to make it move based on the current board state. Then the gradient part. So the gradient draws a gradient background on a canvas using two colors. Scroll a little down. Okay. The last one is the draw gradient text. Draws gradient styled text on the GUI canvas. So here is the challenges. The challenges we faced, such as implementing complex AI logic, ensuring accurate game state validation, and optimizing the algorithm for real-time performance. Overcoming these obstacles enhanced our problem-solving skills. So here we can see the implementing AI logic, game state validation, user interaction, GUI design, error handling, and efficiency. This next slide. And here the last one is conclusion. In this conclusion, this project demonstrated the practical application of AI in game development. We successfully combined robust algorithm with creative design, resulting in an engaging and efficient tic-tac-toe game. This project demonstrates the practical application of AI in game development and highlights the importance of robust logic and creativity in software design. So this is it. Thank you. Assalamu alaikum.